Welcome everyone. Let's begin the discussion of part E of problem number 1. Okay, in this case you have to integrate 3x divided by x minus 2 to the power 2, right? For this case actually there are many methods, right? So I will do this problem in two methods, right? First I am going to use substitution. So this is my method 1, it is substitution. Okay, I did very similar problem to this one in the class, something like 3x divided by x minus 1 to the power 100 or something, right? So what is the suitable substitution? I am going to substitute u equals x minus 2, right? Then what can we say about the derivative of u? That is equal 1, which would give me du is equal to dx. Okay, now I would come back to my integral. I is equal to integral 3x divided by x minus 2 to the power 2 dx. Okay, right. So now I am going to use my substitution, right? Now I know that u is equal to x minus 2. This would give me x is equal to u plus 2, right? So what would be my I? I is, I can take 3 out. So integral of x divided by x minus 2 to the power 2 dx, which is equal to 3 times. Now I am going to use my substitution, right? Instead of x, I can put u plus 2, right? And x minus 2 is going to be u. So x minus 2 to the power 2 would be u square. And what is my du? It is going to be dx, right? So therefore dx, instead of dx I can write du. Okay, now my integral would become 1 divided by u over u square plus 2 over u square du. Okay, so it is going to be 3 integral 1 divided by u plus 2 divided by u square du. Okay, right. Now I can decompose this integral into two integrals. Integral 1 over u du plus 2 times integral u to the power negative 2 du. Okay, now what is the integral of 1 over u? That is ln u, right? That is one of our basic integrals, right? So what is the integral of u to the power negative 2? That is u to the power negative 1 divided by negative 1 plus arbitrary constant, right? So I would get 3 times ln u minus 2 divided by u plus arbitrary constant, right? Now finally I have to remove the substitution that I used. Now u is going to be x minus 2. So instead of u I would put x minus 2. Okay, this is my final answer. Okay, let's do this problem in another method, right? Method 2 is partial fractions. Okay, so my function is 3x divided by x minus 2 to the power 2. I am going to find partial fractions. So it is going to be a divided by x minus 2 plus b divided by x minus 2 to the power 2. right? So I would get, if I multiply both sides by x minus 2 to the power 2, I'll get 3x equals a times x minus 2 plus b. Okay, right. Now I can find the values of a and b very easily, right? So what can I do? First I can substitute x equals 2. Then I would get 3 times 2 is equal to a times 0 plus b. So this would give me b is equal to 6. Okay, right. Then I can equate coefficients to find b. Or I can substitute x equals 0. Right, let's substitute x equals 0. Then on my left hand side I would get 0, and on the right hand side I would get a times negative 2 plus b, right? So I'll get 0 equals negative 2a. I already know my b value, it is 6. Okay, so this would give me 2a is equal to 6 and a is going to be equal to 3. Okay, now I finished finding partial fractions. So 3x divided by x minus 2 to the power 2 is going to be equal to a divided by x minus 2, that is 3 divided by x minus 2 plus b divided by x minus 2 to the power 2. b is 6 divided by x minus 2 to the power 2, right? Now let's evaluate this function. Now integral of left hand side is going to be equal to integral of right hand side. Okay, so if I take 3 out from first integral, I would get 1 minus x minus 2 dx, and if I get 6 out of the second integral, I would get x minus 2 to the power negative 2 dx, right? So what would be the integral of 1 divided by x minus 2? That is going to be ln x minus 2 plus 6 times, what is the integral of x minus 2 to the power negative 2? That is x minus 2 to the power negative 1 divided by negative 1 plus arbitrary constant capital C. This is equal to 3 ln x minus 2 negative 6 divided by x minus 2 plus arbitrary constant. Okay, now this is my integral value, 3x divided by x minus 2 square dx. Okay, okay, this is my final answer if I use the method of partial fractions. Okay, right, let's move into our next problem. Okay, it is the integral of 2x divided by x square minus 3. Let's call this integral I. I is equal to integral 2x divided by x square minus 3 dx, right? So if you see this problem carefully, you can find out the derivative of the denominator is appearing in the numerator, because denominator you have x square minus 3 and its derivative is 2x, right? So what is the substitution that you can use? I'm going to use u equals x square minus 3. So du by dx is going to be equal to 2x. So du is equal to 2x dx. Okay. Okay, so 2x dx is going to be equal to du, right? Now I can insert my substitution. 2x dx is du and x square minus 3 is u, right? So my integral is integral 1 over u du, right? So this is a basic integral. We know what is the value. That is ln u plus arbitrary constant, right? Okay, now I am going to remove u. Ln x square minus 3 plus arbitrary constant. This is my value I. Okay, I hope that is clear, right? So let's move into our next problem. That is this one. Part G of problem number 1. Okay, again I will call this integral as I is equal to integral 1 divided by x square plus 9 dx, right? So what is the suitable substitution in this case? It should be x equals square root of 9 tangent theta, which is equal to 3 tan theta, right? So what would be my derivative? Dx over d theta is going to be 3 secant square theta. So dx is going to be 3 secant square theta d theta. Okay, so my I is going to be, instead of dx I can put 3 secant square theta d theta, and my denominator is x square plus 9. So x square is 9 tangent square theta plus 9. Okay, so I would get integral 3 secant square theta d theta divided by square root of 9 1 plus tangent square theta. Okay, now again from the Pythagorean identities we know that 1 plus tangent square theta is secant square theta. So therefore this integral would become 3 secant square theta divided by square root of 9 secant square theta d theta, right? Now what is the square root of 9 secant square? That would be square root of 9 is 3 and square root of secant square would be secant theta. So it is going to be integral secant theta d theta, right? Now this is a standard integral. So what is the integral of secant theta? It is going to be ln secant theta plus tangent theta plus arbitrary constant, right? This is the value of my integral I. Okay, I hope you understood these 3 parts that I discussed. So in the next video I will discuss next parts. Thank you for watching.